Now we're in chapter 3. And in chapter 3, the topics we're going to be doing is describing, exploring, and comparing data. In this chapter, we'll use calculator. And if you have problems with a calculator, look at calculator notes. On Brightspace to give you an outlook of what keys to utilize and how to take care of your calculator. All right, let's start with section 3.1, which is a measure of center. Measure of center. And that is the description of the data numerically. Now, we've studied these principles all through our elementary to high school experience. I think it starts with the mean, and average is what we use, and other concepts that happened between sixth grade and then finishing high school. The next material will be heavy use of the calculator to arrive at some of the computations that give a value to measures of central tendencies and variances within data set. Those two items are the general focus. Some of these concepts have been experienced before, but the focus is not on comparing is now is now on comparing, assessing, and determining the data tendencies. So we're going to talk first about some of the characteristics. And this is the center of data set. In particular, we present measures of the center, including mean and median. Our objective is not only to find the value of each measure of center, but also interpret. Well, let's start with mean. Mean is the arithmetic calculation on the average of the data. Examples is a grade for the course or general cost of a vehicle and what the average is. And then you add other features that change it slightly. So we have the formula here. And we introduce the sigma. To mean, add, or sum. In the variable x, represents each data, each element, I should say, each element in each, well, I'll just say number. Set. All right, and n is the total um, the total number of elements. But we're not concerned about it because we're going to be entering this data um, into the calculator, and it will spit it out. But you understand what the formula says. And normally, when I teach this in algebra classes, I always write the sum of the data divided by the number of data. And that's what I've just explained. But we are in statistics and we need to recognize some of the symbols that refer to action, and that's that sigma. The important properties of the mean. Sample means drawn from the same population tend to vary less than the other measures of center. The mean of the data set uses every data value. Nothing is omitted. Everything is utilized. A disadvantage of the mean is that just one extreme value, and there it is, an outlier, uh, can change the value of the mean substantially. And that means distort. And but we follow it anyway. Then what happens is we call this disturbance of distortion resistant. Resistance is a statistic is resistance if the presence of extreme values does not cause it to change very much. In other words, you can have an outlier, but it won't change the outcome very much because of it. And that means large volumes of data. So I described this earlier, but we had to consider the fact that X bar stands for sample mean, that means average, and then the mu, which is a funny looking U, is the population mean. And these are very important because they're compadres. I will talk about it later, meaning what about the standard deviation notation? But we're talking about the mean. So we know the mean is the sum of the data divided by the number of data. The median is the middle number of the set. The median of the data set is the measure of the center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. I always use in my lectures increasing. Important properties of the median. The median does not change by large amounts when we include just a few extreme values. So the median is resistant to measure of center, which is a very good tool to understand. If it's not resistant, well, then the outlier affects the whole premise of the mean, but not in the median because it's the center value of that data. The median does not directly use every data value. For example, if the largest value is changed to a much larger value, the median does not change. So again, that resistance factor is always present. Now, for finding the median of a set. And again, we'll be using our calculator, but you have to understand that in order to find the median, uh, we have to sort the data in an order. Ascending is what I'll be using. If the number of the data value is odd, the median is a singular middle number. If the number of data values is even, then it's found by computing the mean of the two. All right. So let's give you an example, and it's going to be very easy. All right, we have 1, 2, 3, 4, 5 numbers, and we want the median. So it would be 8. And therefore, there are 2 and 2. These must match for the median to be a number. It's a middle number. Well, suppose I add one more. Now we have 6 numbers. And let's make that a 10. Okay, 6 numbers. So in this case, I have 3 and 3. So I need what? The middle number. So that would be 8 plus 9 divided by 2. 17 divided by 2. And of course, you already knew it was 8.5 is the median. So that's what they mean about the condition. Well, now we're going to talk about mode. So we have the mean as the average, the median as the center value once the data is ordered, and now we have the mode. The mode of the data set is the value or values that occur or occurs with the greatest frequency. Greatest is the key describer of mode. Greatest means that it has the most repetition in the data. And you can have one or more than one or none if it's singular in scope. Then, and I wrote there, when no data values is repeated, we say there is no mode. All right. Now we have something kind of interesting, and it is a quick and dirty way of finding the median. And it isn't good because it includes the extreme ends of the data, and it's called the mid-range. The mid-range of the data set is the measure of the center that is the value midway between the maximum and the minimum values in the original data set. It is found by adding the maximum data value to the minimum data value and then dividing by 2. So we have that to consider. Now remember that we have entered data. So I only inserted this, but we've utilized data entry and sorting in chapter 2. But for purposes of lecture, you can take the picture with your phone and look back at those notes. And we're going to add new commands on our TI-84. All right, here we go. So how to calculate or compute the 5-number summary and the mean, median, and range. This is the app that helps find values for chapter 3. Now this is new. Now remember the data has been entered and we're using only one set of collected data. That's important because we're not comparing, we don't have sets of data that are matched in relationship. So this is one set of data. So we've entered our data into line 1. Then we enter our, I'll do green, stat, arrow over on that top menu, and highlight calc, C-A-L-C for calculator. Select one variable stat by using the enter key. will appear on the home screen with line 1, enter, frequency just enter, and calculate is another enter. Enter, 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 after we paste the one variable stat. Okay, the window with information will appear. If the 5-number summary does not appear, then turn the feature on by second 0, and that gives you the catalog. And then you arrow down till you see the entry diagnostic on and enter. And it'll say done on the home screen. This will activate all of this, the 2 windows. Excuse me. And from this summary, we can get all the information we need. All right. So let's look at what happens after you enter. You're going to see an X bar, and the X bar is the average, the mean of the data of a sample or a population. It'll come out as an X bar. Then you have the sigma X, which means the sum of the data entered. We don't use that in this class, but it could come later if you take advanced statistics. Then we have the sum of X squared, sums of each data squared, used in statistics, but not in our class. But we're going to be using these. Okay. We will be using this value. Sx is sample standard deviation, and delta X is population standard deviation, and that's used in section 3.2. Then we arrow down. And once we arrow down, then we can see the second window, which gives us the 5-number summary. All right. Well, in the 5-number summary, we have the lowest value. We have Q1, which stands for quartile, and I put quadrant. Oh, my algebra, right? Quartile 1. The median, Q3 is quartile 3. I'll correct this on my final notes. And max is X, highest value of the data. As you recall, we said the mid-range is max X minus min X divided by 2. Well, that would be this feature here and this feature here. And then we can see that the median represents the median. So we can get those two. We can get the average, the min max, and then we can even get the range, because we know that we're going to find this out a little bit later. Range is max X minus min X. That's the span of the data. So we get a lot of information from this. And we're even talking interquartile range, all kinds of things from this 5-number summary. So let's take an example, and we will look at this example. It is find the mean, median, and mode and mid-range for the data. All right, so the first step is enter the data. On stat, edit. All right, so we're going to do that first. Everybody get their calculators out. All right. And remember, garbage in, garbage out. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20, 25 numbers. I'm going to hit the stat key. It's under edit, enter. I've got a whole bunch of junk, so I'm going to clear, up arrow, clear, enter. Now I'm going to enter it any way I like. It doesn't matter if I go across or uh, vertically. So I'm going to enter my numbers as carefully as I can. It is in order, isn't it? Oops. Yep. All right. And I notice I have 27. So I have made an error in the data. We said we were going to have 25. It should say 26. So I'm going backwards. 2,000, 1,500, 575 four times, which is, I think, where it is. That's four times, so that's correct. Then I have 500, 425, 375. Okay, now I have two of those. That's correct. 209. The 275 is twice. Oops. There you go. 125, 100. I'm getting 95, 75. Oh, 85, right? 75 is 1, 2, 3, 70, 70, and 39. Wow. Well, that's crazy, right? Okay. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. I didn't see my Bobo. That's the craziest thing. Oh, mercy sakes. I have to clear enter because I do not see my my bobo. I don't. There's three of these, two of the 70, and one of the 39. So where is this mistake? There it is. 175. I had only two of them. I have to delete that one. There you go. Done. Oh, man. I passed that one when I was doing it. It should say when I get to the 2025. Perfect. I'm sorry it took me a while. So now we're going to give it a command. All right. So that is stat, arrow over to calc, heading, and then you're going to choose number one. All right. So let's do that next. So I'm going to hit the stat key, arrow over to calculate, enter, and it'll come automatically to line one. 1, 2, 3, and I get this first window. My first window says that X bar is 368 and 72 hundredths. Then it says that as it stops over here that I have N is 25 elements in the set. So that's good. I'm not going to do the standard deviations yet. I can have a min X that's equal to 39, a Q1, which equals to 80, and then I arrow down, and then I'm going to have the median equal to 200, and Q3 equal to 537 and a half. You can see that because it's even, it's odd data, but it's even after the median, it's going to be uh, the average of the two paired items. Then we're going to have the max X, which is 2000. All right, so we're going to put up the calculator for now. It asks, what is the mean? We're going to write 368 and 72 hundredths. So this is the mean. Then it asks median. Well, MED stands for the median. Okay, so I'm going to put 200 there. The mode. Now we're going to look at our data, and the most I have is that 5. It looks like it's that value there, and it's we don't write it 4 times, we only write it 1 time. So let me put that down. And then it asks for our mid-range. Now remember what the mid-range is. So the mid-range is max x minus min x divided by 2. So I'm going to have the 2000 plus, okay, this number plus the 39 divided by 2. Well, that gives me 2039 divided by 2. And so we can either use the calculator, which is okay, but it'll be 1, 0, and then the 3 is 1, and 19 is 9.5. You can use your calculator for any computations and always check my work. Now, it says, are there any outliers? Well, 39 is small, but the outlier that really grabs us are these two, because it just says 39 and 2000 appear to be outliers, but not really, because the difference here is 31, and the difference here is 500. So that could be right, but it's not. The value of 1500 and 2000 appear to be outliers. And that's because this number here is only $600, and then it jumps up to 1500. So these are extremes, much more so than the other. Now, it's interesting that they have all three. But the gap is the largest here. We can adjust for that one, but not for the other two. All right. So I'm going to stop right there because I'm already talking 30 minutes. And I had to find my error. I thank you very much for listening. We'll catch you on part B of section 3.1.